Hi everyone, in this video we're going to be looking at index laws, so let's just get right into it. So a number written in index form has a base and an index, or you sometimes call a power or an exponent. And so there's a number of index laws that are applied when performing operations with numbers in index form, particularly when we're looking at with algebraic indices. So to quickly go over what we're talking about here, we're saying, say we had the number 7 to the power of 4. As we know, this means 7 times 7 times 7 times 7. That's what we mean by our index notation, where we're saying that 4 is my index. Spell that right. Index. And 7 is the base. So let's get into the index laws. So the first index law is multiplication. Note really quickly that when we're looking at these index laws, we're saying that the bases are always the same. So we see that we have x to the power of a times x to the power of b. The powers don't need to necessarily be the same, however the bases do. So if we're multiplying two things with the same base, we simply add the powers. So we add the powers if we're multiplying two things with the same base. If multiplying was adding, that means division quite logically means that when we're dividing two things with the same base, we subtract the powers. Next, if we're doing power of a power, what we mean by that is, say we have some number to the power of a number, and then we're taking that to be the power of another number. What we do is we multiply these two powers. So we have x to the power of a times b. So we're multiplying. The fourth index law is power of 0, whereby we're saying any number to power of 0, doesn't matter if it's a very large number, a very small number, a negative number, whatever. If it's taken to the power of 0, it will equal 1. So anything to the power of 0 is equal to 1. And lastly, when we talk about negative powers, if we have a negative power, say we're doing x to the power of negative a, the way we can rewrite that to be with a positive power is we take what we have and flip it. We find the reciprocal of it, where we flip it. So we put that into our denominator. So now we have x to the power of a, and that also loses the negative power. So the negative power flips the index, I guess we could say. So let's go into a few examples of how we can use these index laws. So looking at question number 1, I want to simplify 4x to the power of 5 times 6x to the power of 2. Now, before we get to the indices, let's look at those coefficients, which are the 4 and the 6. 4 times 6 simply equals 24. And now that we have 24, we now go look x to the power of 5 times x to the power of 2. That first index law told me that I need to add these two powers. So it's going to be x to the power of 7. Note again that these are both x's. If they were two different letters, I wouldn't be able to combine them. All right, they have to be the same base. Going into the second example, we have 48 over 12x, so 48x8y7 over 12x5y6. So let's first of all look at those coefficients. 48 divided by 12 equals 4. And now x to the power of 8 divided by x to the power of 5. That second index law told me that I need to subtract the powers. So it's just x to the power of 3. And then y to the power of 7 divided by y to the power of 6 is y to the power of 1. However, whenever you have a power of 1, you can really just get rid of it. So we have 4x to the power of 3y. Going into question 3, we have a power of a power. So we have three things inside this bracket. We have the 2, the a to the power of 6, and the b to the power of 2. And we're going to raise each of these to the power of 3. First of all, 2 to the power of 3 isn't 2 times 3, which is equals 6. 2 to the power of 3 means 2 times 2 times 2. We're multiplying 2 3 times. So 2 times 2 is 4, and then 4 times 2 is 8. So 2 to the power of 3 equals 8. And then for the rest of these, you remember that our third index law says that I multiply these two powers. So a to the power of 6, a to the power of 3 is a to the power of 18. And then b to the power of 2, b to the power of 3. Again, I multiply those powers, giving me b to the power of 6. Looking at this next one, we have 5 plus x to the power of 0. That fourth index law said that anything to the power of 0 equals 1. That doesn't mean the answer instantly just becomes 1. We're saying this is 5 plus x to the power of 0, which was 1, which equals 6. Similarly here, I have 7 x to the power of 0. We know the x to the power of 0 equals 1. However, that 7 isn't being raised to the power of 0. This is basically saying 7 times x to the power of 0. X to the power of 0 equals 1. So 7 times 1, which equals 7. This last question here, I have 1 over x to the power of 7. And I want to rewrite this with a negative index. So I want to get rid of the x7 on the bottom. I want to take it to the top. But to do that, we need to balance that out with a negative index. So the way we do that is we can simply move it to the top and have x to the power of negative 7. And that's all there is to it. Anyway, hopefully this has been pretty basic with the index laws. Go through the exercise showing how to use each of these. Thank you.